Hi everyone. Let's start the next part of MCQ, Resilient Architecture. In this video, we are having a 10 questions about the resilient architectures. So let's start. A company runs a stateful application on the EC2 instance and want to improve the availability without redesigning the application to be stateless. What is the simplest improvement we can do? So the options are deploy the instance across the multiple availability zones simultaneously, use a EC2 auto recovery to automatically recover the instance if the underlying hardware fails, manually restart the instance every hour, move the application to AWS Lambda. ठीक है, so we can eliminate the question C or D by because sorry, option C and D, because manually restart of the every instance in every hour is going to be very expensive. So we are not going to go with this and move the application to the AWS, which is also a hard task. If we are having use EC2 auto recovery, automatically recover the instance if the underlying hardware fails. This is going to be a right answer. See why? Because it is automatically recover the instance and it becomes impaired due to the underlying hardware or the system issue without recurring a stateless redesign. We can go with the EC2 instance, deploy instance across the multiple availability zone. It is also going to be a very expensive. We are adding have to eliminate this as well. So B will be the right answer. Let's come to the next slide. A company wants its relational database to the automatically failover to stand by in a different availability zone with the minimal downtime during a primary instance failure. Which RDS feature should it enable? Read replica, availability zone deployment, automated snapshot only, across region replication. So answer will be multiple availability zone deployment. See, because here we want a different availability zone with a minimal downtime. We can go with the multiple availability zone deployment. RDS having this feature. We use read replica when we want a high throughput with the read and write. For the better performance, snapshot is automated, not here. Use cross region replication is also not useful here. The application experience a predictable traffic spikes and need to automatically add or remove EC2 instance based on the real-time demand. Which service combination should be used? So options are EC2 auto schooling with the target tracking policies based on CPU utilization, manual launching instance during expected spike, and a single large EC2 instance size at peak load AWS batch with a fixed number of compute in moment. So manual launching the EC2 instance during every spike is going to be a very difficult. We have to eliminate this. Okay, and the single large EC2 instance, it is also not a good way because we are unable to scale, and AWS batch for the fixed number of compute environments, and EC2 auto scaling with the target tracking policy based on the CPU utilization. It is, we can go with that because automatically adjusts the capacity to maintain the target matrix like CPU utilization, matching resources at real-time demand. So EC2 auto scaling would be the good right answer. So we are also have to eliminate the AWS batch option. Let's come to the next question. The company wants to decouple an application from a slower backend processing service so that a spike in incoming requests does not overwhelm the backend. What should be used between them? Amazon SQSQ, a send copy of the front end, a large EC2 instance from the backend, or Amazon CloudFront. So answer will be A. See why? Because the second copy of the front end is also going to be eliminate, and large EC2 instance for the backend is also going to be eliminate. Amazon CloudFront we use for the global data usage or and all. So they deploy a web application from the slower backend processing service so that a spike in coming request does not overrun the backend. Okay, so the incoming request of the spikes will not affect the backend, and application want to decouple, we can use a SQS queue so that in a structured way the services or the request will come and execute. Because when SQS queue buffers a target, like buffers between the backend or front end, then allowing the backend to process at its own place and absorbing the traffic spikes. So we are independent the front end and the back end with the help of SQS in all these of options. Let's come to the next slide. A company needs its critical application to continue operating even if an entire AWS region become unavailable. What is the required at a minimum? So the options are deploy across a multiple availability zones within a one region, deploy the application and its data in at least two AWS regions with a failover mechanism, use a single NAT gateway across zones, enable SC versioning. So here the question is demanding for the critical application to want to continue the operating even the entire AWS region become unavailable. Okay, so if one reason is unavailable, we request for the one more reason. So there is the option B will be that, because option A is having a one reason concept, so we want a reason failover mechanism reason specific. Okay, so we can go with the option B. So surviving a full region outage require active presence or fast recovery capability with the replicated data in a second region, and plus a way to fail over such a Route 53 and health check, we can go with the option B. The company wants to automate a durable backups of the RDS database with the availability to restore to any point within these last 7 days. Which features should it use? Manual snapshot only, automated backups with a point in time recovery, EBS snapshot of the underlying volume, or cross region read replicas. So question is asking about the automated and durable backups of the RDS database. Okay, so durable backups, it's going to be a automated backups. We have the point in time recovery automated backups we can use with the ability to restore any point of within a 7. Like question is already giving the answer. So we can go with the option B. So the RDS automated backups store the transaction logs and enabling a point in time recovery to any second, like within the configure retention window we can use. So we can go with the option B will be the right answer. Come to the question number 17. A distributed application must retry a failed operation without overwhelming the downstream service during an outage. Which pattern should be architect implement? Immediate retries with the no delay, exponential backoff with the jitter, or infinite retries on the fixed 1 second interval? Disable retries entirely. I go with the option B, exponential backoff with the jitter. See, because whenever we are implementing any circuit breaker pattern on the retry failed operation without overrunning the downstream service, so we go with the exponential backoff jitter, because it spreads out retry attempts and reduce the chance of overwhelming the recovery downstream service, which is recommended a resilient pattern. We can go with the option B. Question number 18. A company stores a critical file in S3 and wants a protections against the accidental overwrites or deletion while still allowing a normal object updates. What should it enable? S3 versioning, S3 transfer acceleration, S3 request phase, S3 static website hosting. Simple, it is going to be S3 versioning because whenever it is going to be asked a protect against the accidental overrides and deletion. So if I use a S3 versioning, I can easily get an object updates normally with the help of versions of the S3. Okay. So S3 versioning, I keep every version of an object so the accidental overrides or delete can reverse by restoring a prior version and we can use that. So request page and static website hosting transfer system all are useful in this question. The application uses a DynamoDB and needs an automatic continuous backup with the ability to restore to any point in a time within the last 35 days, which features meets this on-demand backups on the DynamoDB point in time recovery, DynamoDB streams, global tables. So this is very easy because we are with the having an option of DynamoDB point in time recovery because the question is already asking a need automatic and continuous backup with the ability to restore any point of in time, right, within the last 35 days. So DynamoDB continuously backup the table data and allows to restoring any second in the preceding 35 days without impacting performance. Okay, application load balancer will be the right answer with the health checks. Let's meet in the next